Numbers 10 through 12, our directions tell us to write the rule in coordinate notation to describe the transformation. Coordinate notation is the same thing as an ordered pair rule. Remember, an ordered pair rule always says what you're doing to the general point x, y. You're mapping it to a new point by doing something to the x and doing something to the y. Well, we've already got the first part of the ordered pair rule that is given to us. We just have to fill in the effect on x and y from each one of these transformations. On these figures, make sure that you really pay attention to which one has the prime symbols on it, because that's the image you're going towards. So on this one, I can see that I have a v prime. It's actually kind of small there, and t prime here, and n prime and m prime. And so this is my pre-image, the one without the image, the prime notation on it, without the little apostrophes. So I'm starting with this one and I'm going to this new one here. Okay, so I can see N starts in the second quadrant and ends up in the third quadrant. M starts in the second, ends up in the third. T starts in the first, ends up in the second. And this V was in the third and ends up in the fourth. So if you notice, everything switched over one quadrant in this direction that we call counterclockwise. And so since everything went one quadrant counterclockwise, we know that's a rotation. And when you only go over one quadrant, we know that's a 90-degree rotation around the origin. And again, we're going counterclockwise. And so we're going to write the ordered pair rule, what happens to the x and what happens to the y when that happens. So remember, with the 90-degree rotations, those are fairly new to us. The two coordinates are going to switch places, and only one of them is going to change its sign. And so what I always do is I draw an arrow in the way that I'm going. So I'm going to draw an arrow this way because I'm going counterclockwise, and that reminds me to change the sign on the y. So I'm going to write the finished product should be the opposite of y, because it switched and changed signs. And the x switches too, but it doesn't change signs. So my rule is opposite y, x. And I can check that with one of my points. So what I mean by that is we can look at N. This point right here has the coordinates -1, 2. If I apply my rule to it, I want the opposite of y, so the opposite of 2 is -2, and then my x, which is -1. Is that where N prime is? -2, -1. Yes. And so I can feel good that my ordered pair rule is correct. And I could check it with the other points as well, just to make sure, but I'm just going to say that that is correct, so we'll move on. On the next one, we can see that these points do not have the prime notation. These do. So this is my pre-image, and the other figure is my image I'm going to. And so I can see point R here, and here's R prime. W here, W prime. A here, A prime. G here, G prime. So I can see everything was reflected. This figure has been flipped, not slid up. It didn't rotate. It has just been flipped over this axis, which is the x-axis. So every point that I started with and its image are the same distance from that line on the other side. And so remember your rule: when you reflect across the x, since you're doing up and down movement, you're changing the sign on the y coordinate. That's the up and down coordinate. So your x is not changing, your y is just changing signs. So you can see that with point W, the coordinates were 1, -2, and it was mapped to W prime, which is at 1, +2. So see, they didn't switch. All that changed was the sign on y. It went from negative to positive in that case. All right, on number 12, again, you want to locate the one that doesn't have the prime symbols on it. So here is my figure that is without the prime symbols. So that's my original, and I'm going to this new figure. So here is V, here is V prime. Here is, can't tell what that is, maybe a J to J prime. an I to I prime, a T to T prime. So they're all going in the same direction. This figure has just been slid up and to the left. And so this is a translation. I can see that V went to the left one and up one. Same thing with whatever this letter is. It went left one, up one. I went left one, up one. T went left one, up one. So if we were writing that with a translation vector, left one is a negative one, up one is a positive one, left one would go in the X spot, up one would go in the Y spot with angle brackets. But when you give ordered pair rules, you always represent as ordered pairs, which means they go in parentheses. So you're going to tell what you're doing to the X. So don't just put -1 there. You have to say what you're doing to the X. Since you're going left 1, you are subtracting 1 from the X coordinate. If you were going right, you would add, but when you go left, you subtract. And then what am I doing to the Y? That's the up and down movement. Since I'm going up 1, I'm going to add 1. If I was going down, I would subtract. So again, you can test a point on this. We can use V, for instance. The coordinates of V are 1, 1. If I apply this rule, I would subtract 1 from the X. So 1 minus 1 is 0. And then I would add 1 to the Y. 1 plus 1 is 2. Is that where V prime is located? Yes, it is. So I can feel good that my ordered pair rule is written correctly. Remember, you're not asked to write it in vector notation, so make sure you use the correct form when giving those answers.